statisticians. This is Professor Sampson from PS I Love Math. Back with another statistical banger. Today we're going to finish our discrete probability distribution by working on the binomial distribution theorem. Okay, don't forget to like, comment, and subscribe. What's good, my statisticians? Here we go talking about binomial distribution. Interesting section, so we're going to get right into it. It's actually going to be a little long, so we're going to do this because I'm a savage.
Oh my God!
So binomial distribution. We just left when we were talking about discrete probability distribution. Discrete probability distributions is a general term, and then we have different types of discrete probability distribution. Now, we will only cover binomial distribution, but there's also Poisson distribution, there's hypergeometric distribution. There are different types of distribution, but again, we'll only cover binomial distribution. The binomial distribution is a special discrete probability function. So let's get that definition typed up here. The binomial distribution is a special discrete probability function for problems with a fixed number of independent trials where each trial has only two possible outcomes and one of these outcomes is counted. So what does this mean? A common binomial distribution is like flipping a coin because you know there are a fixed number of independent trials and you know the possible outcomes, and then you can say heads or tails. So the binomial distribution has specific properties that we need to take a look at and go over. These are the properties for a binomial distribution. The first one is that the experiment consists of a fixed number of independent trials. A fixed number meaning that you have to say, I'm going to throw this coin 10 times. The second one is each trial has to be independent of the other, meaning that you can't be without replacement. So like when you flip a coin the first time, when you flip it a second time, it's not dependent on what you got the first time. That's what it means to be independent. Then for each trial, there are only two possibilities, and this is important. One is success and one is failure. There are only two possibilities, one being success and one being failure. The next property is that every trial, the probability of success, we call that P, and the probability of getting a failure, 1 minus P. For my class and in other textbooks, you may see 1 minus P also labeled Q, and I use Q often. Number 5 is the binomial random variable X counts the number of successes in n number of trials. So if you're saying you're looking for heads, then success would be the number of heads. And the last one is a binomial distribution that the mean is equal to n times p, and the variant is n times p times what I would call q. So if you're in my class or maybe in another place, q is 1 minus p. That's what I call q. Q is the number of failures. That takes care of the requirements for something to be a binomial distribution. So just know some of your questions in your classes may be, is this a binomial distribution? And all you need to do is to go through these 6 properties, and if it doesn't meet one of these properties, then it's not a binomial distribution. What is the probability for this binomial distribution? Probability for a binomial distribution. Now, this is why we learned combinations from before. So let me show you the probability for a binomial distribution. This is the formula. This is why we learned combination. I'm just going to show you the formula. We will not be using the formula, but just to show you what the formula looks like, a formula for this is actually a combination formula. Okay, we know n is the number of trials, p is the probability of getting the successful trials, and x is the number of successes that you have. So this is actually the formula for it, but we won't be using a formula. We'll actually be doing these in our calculator. Now, because we're going to be using our calculator for these functions, I'm going to walk you through the functions using the calculator and what it actually means. Now, you will have to do a little handwork because the calculator for this information isn't just you punch it in and then you get out the answer. Sometimes you have to do some work. So let's talk about the calculator in this situation. Now we're talking about binomial distribution, and in your calculator you have 2 functions for binomial distribution, one for PDF and the other for CDF. 2 different functions. Now in your calculator, hold on with me because I know you're confused.
I have no idea what you're talking about.
in your calculator, the PDF function means equal to. That's what it means. It does equal to. That's all it does. And the CDF function does less than or equal to. It's a cumulative function in your calculator. But these are the only things that your calculator can do. Your problems are going to be different from this, but these are the only things your calculator can do. So you're going to have to manipulate. And cumulative function means less than or equal to the number that you're talking about. So let's get into the examples and see how we're going to go through these particular ones. So as I said, these are the only two functions that your calculator can do. There's a binomial PDF and a binomial CDF. PDF means equal to and CDF means less than or equal to. So any of the other functions that you need to do in a calculator, you need to manipulate them to be the either equal to or less than or equal to, but you won't be manipulating anything to be equal to. But let's start with an example. So our example will be P of X is equal to 3. So the probability of X equals 3, N equals 5, and P is equal to 0.4. So this is your question. So as you look at it, you look at the question and you say, well, what is my probability? You see that they're asking for equal to. Well, that's cool because we know equal to is in the calculator. Now, you know N is the number of trials. That means there are 5 trials. X is the number that you're looking for, and probability is the probability of getting whatever that particular number is. Now, what you're looking for is the probability of getting 3. This is a general probability. Probability is equal to 0.4 is a general probability. So what you're looking for is a probability that X is equal to 3. Cool, because your calculator has that function where you can just put in X is equal to 3. So when we pull up our calculator, right, we go into distribution, which is on top of the VARS button. So if you look on top of the VARS button, VARS, you'll see distribution. So you hit second, then VAR. And if you go up or down, I go up. If you go up, you'll see binomial. That's why you have to know what you're talking about, because if you take a look at this, there's normal, PDF, CDF, there's Poisson, there's geometric. You have to know which one you're talking about, but we're only working with binomial. So you go up to binomial PDF. Now I'm going to switch off, because if you have an 83 or a younger 84, then you won't see what I'm about to see, and then I'll tell you how to do it. So you hit enter whether you're in either one of those calculators. Now, if you have my calculator, you're going to get this. But hold on, just stay right there if you have a older 84 or an 83. So I'm going to put in a number of trials. So for my problem, the number of trials was 5. The probability was 0.4. And then X was 3. What did we choose? We chose PDF because PDF is when it says equal to. Now, if you have the 83 or younger 84, what popped up on your calculator is this. It said binom PDF with a parenthesis. You have to put in NPX. So you have to memorize NPX. So what you're going to put in is N, which was 5, comma, which is on top of the 7, N, which is 5, comma, P, which is 0.4, comma, X, in this case, which was 3. So you have to memorize NPX. I don't have to do that in a newer version. So you all good to go. Once you do that, you hit enter, you'll get your answer. The answer is 0.2304. And remembering, if you're in my class, probability is rounded to 4 decimal places, 0.2304. Let's do another one. P of X is less than or equal to 8, comma, N equals 12, and P equals 0.1. So you look up, you'll say, is this equal to or less than or equal to? Yes, it's less than or equal to. So then I choose what function? I choose a CDF. So you just go in and you choose the CDF function in your calculator. So now you go in and you go to your distribution, you go to binomial CDF, and don't forget, if you have the 83, younger 84, you need to put in NPX. Other than that, we're going to put in the numbers we have. So the number of trials for that was 12, the probability was 0.1, and then the X value was 8. Right? And see up at the top, this is a CDF function. So your answer is 0.9999, which is actually 1. But remember, for my class, it still has to be 4 decimal places. But so the answer that should be written is the probability that X is less than or equal to 8 equals 1, 4 decimal places, because you need 4 decimal places, whether it's a 0 or not. So those are the easy ones where you're already given an equal to or less than an equal to. So let's switch up how it looks and also switch up what we're asking. This example says N equals 8, P equals 0.2. And then I'm going to throw in P is fewer fewer than 3. So you just need to know how to translate that P, but P is fewer than 3. The first thing you need to do is translate that in P such that X is what? Fewer than 3. What's fewer than 3? Less than 3. Does that function exist in your calculator? PDF is equal to, CDF is less than or equal to. Those are the only two functions that exist in your calculator. This function doesn't exist. So you have to make this function look like this. It has to be a less than or equal to be put in your calculator. So let's think about this. We got 8 possibilities, as I'm going to list to give you an idea of what's going on. And this says less than 3. So what numbers in your n is less than 3? That would be 2, right? And 1. Those are the numbers less than 3 because we're talking about discrete. So there's no 0.25 and none of that stuff. There's no decimals. It's just anything less than 3. Since it's only discrete, that means they're whole numbers. So the numbers less than 3, and it's actually 0. Less than 3 is 2, 1, and 0, correct? So how do we write that? Since we know that less than 3 is 2, 1, and 0, how do we switch that to less than or equal to? Well, that would be less than or equal to what? To 2. Less than or equal to 2 is the same thing as less than 3 if you're talking discrete variable. Less than or equal to 2 is the same thing as less than 3. These are the same. So now we have what we need to put in our calculator. We have n equals 8, p equals 0.2, and then now what are we going to put in for x? And what are we doing, CDF or PDF? You're doing CDF. We're always doing CDF because PDF is only when it's exact. The number of trials was 8, and then we did 0.2, and then now the number is not 3, the number is 2 because that's the new number that you set up. So that answer is 0.7969. So the probability that x is less than 3 is equal to 0.7969. N equals 15, p equals 0.9 of 14 or more. So let's take a look at this one. First, we got to change this because sometimes it's given to you this way, but sometimes you have to change it. So x is what? X needs to be 14 or more. How do you write that? X is 14. That means greater than or equal to 14. It's equal to 14 because it says 14, or more is everything greater than. Now let's take a look at this. We have 15 numbers, 14 or more. So x is 14 or more. So if we look at that, that means we have this number 14 and we have 15. That's 14 or more because we had n is equal to 15. So what do? Is greater than or equal to something that our calculator can do? No. Our calculator can only do what? Equal to or less than or equal to. So we have to somehow change this in a way that we can find the less than or equal to. So if you have x is greater than or equal to 14, what would change in less than or equal to mean? In this case, we have to use the complement. We have to use its complement. Remember when I explained complements in the sections before, something plus its complement is equal to 1. P of x plus p complement of x is equal to 1. So if we want to get p of x, we might say that's 1 minus p complement of x will give us ultimately what we're looking for. And that's what we have to do with this greater than or equal to. The complement of p of x is greater than or equal to 14 is all this stuff, right? The complement, the opposite. This is greater than or equal to 4. This is the greater than or equal to 14. And this, all this other stuff is the complement. And we have to write it as less than or equal to, so it's less than or equal to 13. That's the complement. Now, do we find the complement? If we found this, have we found the answer? No. What do we found the answer to? We put this in our calculator. Have we found the answer to our question? No. We found the answer to probability of x is less than or equal to 13 because that's what we would have put in our calculator. That's why sometimes you have to be smarter in your calculator. The probability of x is greater than or equal to 14 is equal to 1 minus the probability that x is less than or equal to 13. So we do put it in our calculator. We go through and we put the numbers in our calculator. You know, we go to the distribution, we go back to our CDF, we put in our numbers, which were n was 15, p was 0.9. Our new one was 13. So that gave us the probability. So the probability that this is less than or equal to 13 is 0.45095, which means you got to round it up. So that's 0.4510. And we still didn't answer our question. So our question, you see how I'm writing it? I'm letting you know. Students just be writing all over the paper. They don't tell me where your answer is. Don't circle your answer, and then you don't label your answer. You can specifically see how I carry down my label here so I know the answer. So all we need to do in our calculator right now is just go 1 minus 0.5490. And if you look at it, check it out. This plus this is equal to 1. Remember, something and its complement will be equal to 1. Let's say n equals 30, p equals 0.9, and we're looking for p more than 27. Now let's go back. I want to clarify something because I'm not writing all the numbers this time.
Oh my God.
When we did the list of numbers, when I actually wrote these numbers right here, remember, every number needs to be included when you're talking about something and its complement. So if this included 14 and 15, this had to include 13 and below. You can't leave a number out.
I am so confused.
Okay, what's the complement of greater than 27? So think in your brain. If we have greater than 27, that means we're talking about what? 28. Remember, we're going to 30. That means we're talking about greater than 27 is 28, 29, 30. We need the complement. So we need everything that's not included with 28, 29, and 30. The probability that X is what? Have we included 27 in this? Have we included 27 in this one? No, because it was greater than 27. So the complement is going to be less than or equal to 27. We got 0 through 27. And then the complement is 28, 29, 30. Distribution, CDF, 30.9 again, 0.5886. Is that my answer? Again, this is the common mistake where students put down equals 0.5886 and then they get it wrong. No, I got my ultimate probability of X being greater than 27 to be equal to 1 minus, which gives me 0.4114. So we'll come back after matcha break and do some word problems.
Oh, hell no.
I hope you guys had a good matcha because I had a good matcha. So the problem says, what should I buy? Now, usually, I start off with reading the question, which is, what is the probability that 6 or more of them use their cell phones for guidance on purchasing decisions? That they're looking for the probability that X is what? 6 or more. How do we write that? Greater than or equal to 6. So I already know what I'm looking for. I can already start the problem saying what? That this is going to be 1 minus the probability of what? That X is what? If this is 6 or more, I need what? Less than or equal to what? Less than or equal to 5. I already know that, and guess what? I haven't even read shit.
And
Well, N is equal to what? And P is equal to what? That's what I would do if I didn't want to read or if I couldn't read. I would go back in here and say N. N is the number that we're looking for. The number what? I don't know. I didn't read it, but it says a sample of 15 sounds good to me. And then the probability I know needs to be a percentage in this case because it's a research thing. And here's, look at the other number. There's only 2 freaking numbers in the problem, but we can't use 58%. We have to change that to a decimal. So that's 0.58. Do we even know what the question is about? Nope, but we about to get the answer. Answer's done. It's already finished. The problem is done. We ain't even read what it was about. I'm done. I'm trying to go get my spaghetti. X is greater than or equal to 6 equals 1 minus the probability is equal to 5.
Walk slowly and talk slowly, you are.
0.0479, and so my probability that X is greater than or equal to 6 is equal to 1 minus that, and that's going to be 0.9521. Done. Did I read anything? I still don't know what the question is about. What is the probability that fewer than 10? The probability that fewer, that's less than, is it equal to? No. Fewer than 10 doesn't include 10, so less than 10. I don't even know what the rest of it is. Who cares? The probability that X is fewer than 10, what is that? Can I put this in my calculator? No. We don't have to do the complement rule for this because it's already less than. We just needed to say X is less than or equal to. So if you have 10, X is less than 10. What's less than 10? 9. So X is less than or equal to 9. I still haven't read the problem. Have you? It's the same problem. So N is still equal to 15 and P is still equal to 0.58. Some of you would be in on the test. So we got 15, 0.58, and 9. Now that gave me 0.6570. You don't have to do anything with this problem because these are the same thing. So the probability that X is less than 10. And the last one, C. See, they get easier now. The probability that exactly 8. The probability that X is what? Exactly 8. So that just means equal to 8. We good to go with equal. 0.18998, which is 0.1900. So again, I don't even remember we read the problem. I didn't read the problem. I mean, maybe you read the problem. Here's the problem right here. We'll do one more word problem and that'll be it.
Ain't nobody got time for that.
Okay, actually, I think I'm gonna do two more types of worded problems because these ask a different question at the end. Now, you know, in the last one, I was saying, okay, we don't have to read because it was everything. We do have to read a word problem. I was just expressing to you that the possibility of you getting all caught up in the reading should be relieved when you can see that sometimes that the reading isn't what dictates the problem. But if you don't read this problem, you're going to get it wrong. All right, so we don't naturally not read a word problem. I was just giving you an idea. So let's check it out. The Sugar Bear Candy Factory makes two types of chocolate candy bars, milk chocolate and milk chocolate with almond. On a typical day, 60% of the candy bars being made are milk chocolate and the rest are milk chocolate with almonds. At the end of the day, a quality control expert randomly chooses 14 chocolate bars for inspection. Question A is, what is the probability that half of them contain almonds? So we do our regular, what's the probability that half of them, well, half of them would be, if he chose 14, 7, so that's an equal to, so that's good, contain almonds. So we got n equals to 14, and what's p equal to? Now you need to be careful here because we're talking about the ones that contain almonds. This is where they try to trick you. But the 60% are the ones that are milk chocolate that don't contain almonds. They're asking you about the probability of the ones that contain almonds. So your probability is 0.40, not 60. 60 is for those that are just milk chocolate. So just make sure that, yes, you do have to read it, but I'm saying that you don't have to get caught up in all of the reading. And I just wanted to show you one because I didn't want you to think that, oh, we don't read nothing. We just go in and pop in numbers. Distribution, since it's equal to, we're going to choose PDF, not CDF, and our trials were 14. We were looking for 0.4 and 7, 0.1574. What is the probability that at least half of them contain almonds? At least half. A lot of times when you say at least, students, they'll put less than. Just think of it like this. If I say, give me at least $5, can you give me $4? No, if at least means 5 and above. So at least means greater than or equal to at least that amount. So at least half, and we know half of the chocolate bars was 7. We still have 14 chocolate bars, and now we need the probability of which one. Again, they're talking about the almond bars, so we need 0.4 up. But we got to look here. Remember, we have to use what? The complement. So the complement of this is x is less than or equal to, because that's the only thing we can put in the calculator, 6 and below. The probability that x is greater than or equal to 7 equals 1 minus the probability that x is less than or equal to 6. So we're going to put that in our calculator. The probability that x is less than or equal to 6. This time we need the CDF, not the PDF. So we had 14, and then we had 0.4. So we got 0.6925. So the probability that x is greater than or equal to 7 is going to be 1 minus 0.6925. Again, 1 minus, hit the up arrow to pick that up. And then your answer is 0.3075. So of the 14 candy bars chosen before inspection, what is the variation in the number of bars containing almonds that the inspector could get? Variation. How do we find variation?
You don't know? You don't know?
Okay, so let's do C. Of the 14 candy bars chosen for inspection, what is the variation in the number of bars? So your answer should be, when you finish, number of bars. How many candy bars? What is the variation in the number of bars containing almonds that the inspector can get, right? So we need the number of bars. Well, we need the number of bars. So we need to start off with the mean. The mean is going to tell us the middle value of bars plus and minus that from the standard deviation is going to help us determine our number of bars. So the mean of these bars, mean is equal to n times p. The mean is equal to n is 14. P, since we're talking about almonds, is 0.40. So what's that mean? 14 times 0.40, that's going to give you 5.6. So your mean is 5.6. This is when you have to know what all this stuff means by putting it together. The mean is the middle value, 5.6. We need our standard deviation. How do we find our our standard deviation. We also had the formula for standard deviation. Now, if you look at back at the beginning, I gave you the formula for variance. So the formula for standard deviation is equal to the square root of n times p times 1 minus p, which you know I call q. 14 times p, which is 0.40, times 1 minus p, or q, which is 0.60. So we need the square root of 14 times 0.4 times 0.6. That gives us, remember, rounding rules stay the same for standard deviation and mean. Still one more than the random variable x. Your standard deviation is 1.8. So now we just need to find our number of candy bars by doing what?
I have no idea what you're talking about.
Taking the 5.6, which is the middle amount of candy bars, adding 1.8, and then subtracting 1.8 is going to give you 3.8, and 5.6 plus 1.8 is going to give you 7.4. Now, no, you can't put that as your answer, because the question asked you the number of candy bars. Can you have 3.8 candy bars? And can you round this 3.8 up to 4? No. Have to use your common sense. If you move this up to 4, then you're missing out on the 3 and some change candy bar. So you can't just move it up to 4. So the question is, the number of candy bars is going to be between what two numbers? 3 and 7. So the inspector might get between 3.8 and 7.4, or between 3 and 7 bars containing almonds. So that takes care of that problem. Also learn how to do the mean, because I was going to do another one, but the video is long enough. So if you get any questions about what's the expected value, they're asking you for the mean. Mu is equal to n times p. If they say what's the expected value, they're asking for the mean. Hopefully you got a lot out of our worded problems, to make sure that you knew how to approach the word problems, and to get away from some of that problem that you had with reading the word problems. You understand that the reading isn't difficult, but you do have to understand that you do have to read it, but you don't have to read it as intensely as many of you are trying to read these problems. You just need to read it, and the fact that you need to pull out from it what you need and keep it moving. So I hope you enjoyed this video. Don't forget to like, comment, and definitely subscribe. Help me out to support the channel. This is Professor Sampson from PS I Love Math, and I'm out of here.
Could have fun together when I feel done with having